Welcome to my presentation. In this presentation, we shall see how to find the derivative of a function using limits. So in this example, we want to find the derivative of this function f of t is equal to 3 divided by t, like that. So as a first step, we're going to write the formula down the way we know it. The formula is the slope or the derivative of a function is equal to limit as h approaches 0. The numerator part is f of x plus h minus f of x, this whole thing divided by h. That is the way we know the formula, and therefore as step number 2 we're going to substitute the function in this particular problem, and therefore we can write this as the limit as h approaches 0. The numerator part is going to be equal to 3 divided by t plus h minus 3 divided by t, this whole thing divided by h, like that. As we can see, the numerator part, we want to simplify the numerator part. I'm going to take it to the side here. We have 3 divided by t plus h minus 3 divided by t. We want to find the common denominator. The common denominator is t times t plus h, like that, and we're going to cross multiply. So t times 3 is 3t minus 3 times t plus h. That is what we need to simplify. When we simplify, it is going to simplify to 3t minus, we're going to distribute, the way we simplify is we're going to distribute the negative 3 to every one of the terms inside the parentheses. Negative 3 times t is negative 3t, negative 3 times h is negative 3h, the whole thing divided by t times t plus h. As we can see, we can simplify this to we can simplify this as follows. Negative positive 3t and negative 3t cancels out. Therefore, this is, we are left with negative 3h divided by t times t plus h, like that. So we're going to replace this 3 over t plus h minus 3 over t by this part of the equation. So therefore, we can rewrite this one as follows. Limit as h approaches 0, we can write the numerator part as negative 3h divided by t times t plus h times the denominator. We have h, I can write that as h over 1, and if I were to convert the division into multiplication, I can convert the denominator, I can write the denominator as its reciprocal. H over 1 converts to 1 over h, like that. And therefore now, as we see, we have a h in the numerator, h in the denominator, which we can cancel out, and therefore this expression simplifies to limit as h approaches 0, we have negative 3 divided by t times t plus h. Now, as we can see that as h approaches 0, then t plus h is going to approach to t. Therefore, we can rewrite this one as the derivative or the slope. We can write as f, I'm going to write as the derivative f primes of x, which is the derivative of the function, as negative 3 divided by t times t. So therefore I can write this one as negative 3 over t to the power of 2. So that is how we find the derivative of this given function using limits. Now, if I were to do the same thing using the power rule, I can do this as follows. The given function is as follows. F of t is equal to 3 divided by t. I can write this one as 3 times t to the power of negative 1. If I bring the denominator to the numerator, I can write this one out as a negative exponent, t to the power of negative 1. Therefore, I can write using the power rule. I can write this as the first derivative as follows: f primes of t is going to be equal to negative 3 t to the power of negative 1 minus 1. So I can write this one as negative 3 t to the power of negative 2. So therefore I can still simplify this one as negative 3 times 1 over t to the power of 2. I can express t to the power of negative 2 as a positive positive exponent by bringing it to the denominator, and therefore this is what we have: negative 3 divided by t to the power of 2. And this is what we have when we did the derivative of this particular function using limits. In my next presentation, we're going to see how to find the derivative of a function using limits, and this time we're going to see some application related problems.